Hi Huskies, this video is going to be over factoring. So first we're going to start by factoring a trinomial when a equals 1. That is when we have 3 terms and the number in front of our x squared term is a 1. So if we look at this first example, a couple things I want to point out and things that are going to help you make factoring easier. When this last sign is a plus sign, that means when you factor inside the parentheses, both of those signs are going to be the same, and they're going to be whatever this sign is. Okay, so how we're going to do this is we're going to organize our thinking. So I'm going to draw an X, and the X is just to organize your thinking. And so what we're going to do is, again, right now this is a 1, so it doesn't make much of a difference, but when it is something else, it will. We're going to take this first term, this 1, we're going to multiply it by that last term, and that gives us 18. I like to put the 18 on top, but some people put it on bottom. It's the same thing. It really doesn't matter. Then we're going to take this middle term with the sign included, and that's going to go on bottom. So what we need to think about is what we can multiply to get 18, and because that last sign's a plus sign, we want to add to get 11. So some people may need to write out the multiples. So we have 1 and 18, we have 2 and 9, and we have 3 and 6. So which combination would add to give me 11? That would be 2 and 9. And so because a equals 1, we can go straight to our factors. We have x and x, because if we were to multiply it back out, x times x gives me that x squared. Then you have your 2 factors, plus 2 plus 9. And because a equals 1, that is it for this problem. Okay, so looking at the next one, notice it's very similar to the previous problem. And we have a plus sign again, but this time we have a minus sign in the middle. So it's the exact same process, and I'm going to go through it the same way so you can see. So again, we have a 1 in front of the x squared. We're going to take that term, we're going to multiply it by the 18. So we get a positive 18. I'm going to write that on top. Then we have this time a negative 11. So we still want to multiply to get 18, but now we want to add to get a negative 11. Well, if I'm multiplying to get a positive number, that means that, and I'm adding to get a negative number, what that means is both of my signs are going to be negative. So we have the same combination, it's just now instead of being a positive 2 and a positive 9, now it's a negative 2 and a negative 9. So this factors into x minus 2 and x minus 9. So what I want us to see is that when this sign right here is positive, my signs inside are the same. They are whatever this sign is out in front. So these are very similar problems. The only thing that changed was the signs on the inside, and that's because this sign right here changed. Okay, now looking at number 3. Number 3, notice now we have a minus sign right here. So what that means is our signs are going to be different. So we're still going to do the x. In front of our x squared, it's still a 1. So we're taking that, we're multiplying it by the end. That gives us a negative 18. And then we have this negative 7 that's going to be on the bottom. So now when we think about it, we still want to multiply to get negative 18, but now instead of adding, we need to think about subtracting to get negative 7. Okay, so it's going to be the same combination of numbers, 1, 18, 2, 9, and 3 and 6, but now we need to think about subtracting them. So if I do 1 minus 18, that's a negative 17. If I do 18 minus 1, that's a positive 17, so that's not it. If I do 2 minus 9, that's a negative 7. That's what we want, so the 9 needs to be negative. So now we can go to our factors. So we have 2 and negative 9. So we factor x minus 2, or x plus 2, and x minus 9. Okay, now let's look at this next one, and then I'm going to talk about how we determine what the signs are. So if you look at this next one, it looks like it's different than all the other ones because there's a number in front of our x squared, or we don't even have an x squared, we have an x cubed. But if you notice, each one of these numbers is divisible by 2, and these are all divisible by x. So this actually has a greatest common factor of a negative 2x, which means we need to divide that out first. So that would leave me with a positive x squared, a positive 7x, and a negative 18. So all we did is we divided each term by a negative 2x. Okay, now this right here looks like the exact same problem here. The only thing that changed was the sign in the middle. So the important part is that this is a minus sign, and so we still need to factor just like normal. We're going to take the number in front of the x squared, which is still a 1. We're going to multiply it by the n, and we get a negative 18. Then we take the middle term, and we put it on bottom. So this time we want to multiply to get a negative 18 and subtract to get a positive 7. Well, again, we have the same combination of numbers. So to get a positive 7, this time my 2 needs to be negative, so we can pick that combination. So we have a negative 2 and a positive 7. And so when we factor this, we have x and x, because x times x is x squared. We have a negative 2 and a positive 9. Now, what you can't forget is to drop down that negative 2x right there. And so this right here would be our factored form. So let's talk about this. When this last sign is a minus sign, so like this one and this one, your signs are different inside the parentheses. Okay, now out of your two numbers, the bigger number will take the sign that's in the middle. So right here, our sign in the middle was a minus sign. Our bigger number was 9. It took the minus sign. Over here, our middle sign was a plus sign. Our bigger number 9 had a plus sign. So those are some little tricks that help you. So what you need to do is you need to pause this video and you need to go practice just when a equals 1 to make sure you're good with that concept first. And then after that, come back and watch the next section. Okay, so the next section is a difference of squares. So we are going to be factoring a difference of squares. For a difference of squares, you need to know all of your perfect squares up to about 20. So 1 squared is 1, 2 squared is 4, 3 squared is 9, all the way up to 20 squared is 400. You also need to know the square roots of that. So square root of 400 is 20. Square root of 49 is 7. Okay, so all of those. We have a little formula for this right here that will be helpful. So if you notice that you have two things being subtracted and they are both perfect squares, then you can factor it into a plus b and a minus b. So let's look at this. So we have x squared minus 25. X squared is perfect. So what we do is we're going to take the square root of x squared, and that's going to give us x. 25 is perfect. We're going to take the square root of 25, and that gives us 5. So in our formula, we're going to have x and x, 5 and 5, and then our signs are just going to be 1 plus and 1 minus, and that's it. Okay. Now, looking at number 6, same concept. We see that we have 16, which is perfect. So we're going to take the square root of that and get 4. We have y squared, which is perfect. So we take the square root of that and we get y. And so we just factor it. So we have 4 and 4, y and y, 1 plus, 1 minus. Okay. Looking at this next one, 9x squared is perfect, 64 is perfect. So we're going to take the square root of 9x squared. Well, the square root of 9 is 3. The square root of x squared is x. So the square root of 9x squared is 3x. We have the square root of 64. That is 8. So we have our parentheses. We have 3x, 3x, 8, 8, 1 plus, 1 minus. Okay, so if you want to try this one, pause it, try it. That way you see how you do. So the square root of 100 is equal to 10. The square root of 49x squared is equal to 7x. We have our parentheses, 10 in the first spot, 7x in the second spot, 1 plus, 1 minus. Now, this works when you have a difference of squares. So what happens if we have a sum of squares? So this is some extra information. So let's say we had this right here instead. Well, if you have a sum of squares, what ends up happening is you're still going to have your x go first, and then you're still going to have a 5, and you're still going to have 1 plus, 1 minus, but you have something extra. In this case, you end up having an I with the second term. And so that's how you would factor a sum of squares. So when it's a sum of squares, you get imaginary stuff. Okay, so that's what that would look like right there, or it would be not factorable. Okay, but it doesn't factor with real numbers. That's why they say it's not factorable, but it is factorable. So go ahead and pause the video, go do the practice over the difference of squares. Okay, the last part is the trinomials when a doesn't equal 1. We're going to do the exact same process, but this adds in one extra step. I call this method slide and divide. Slide and divide. Okay, so we're still going to have our x. We always check to see if there's a greatest common factor. There's nothing that goes into all 3 terms. So we're going to take this first term times this last term. That gives us a negative 24. And we want to get this middle term right here. And so that's a 5. Because this last sign right here is a minus sign, we know that we have to subtract to get 5. So let's think about what we can multiply to get 24. We have 1 and 24. We have 2 and 12, 3 and 8, and 4 and 6. So out of these combinations, we want to subtract to get a positive 5, which would be this combination with the 3 being negative. Okay, if we think back to what I said, the bigger number takes this sign. My bigger number is 8, so it needs to be positive. So we have -3 and 8. So when we factor this, we would think we get x minus 3 and x plus 8. But this one has an extra step. Because we did the slide part, that was the 6 times 4, now we have to do the divide part, and we have to divide by that number that we slid by in the very beginning. Okay, so what we do is we simplify. We get x minus 3 over 6 turns into a 1/2. And 8 over 6 turns into a 4/3. But we're not done. Because we have some leftover numbers in the denominator, those numbers are going to slide in front of the x's. So what this factor actually looks like is 2x minus 1, and then 3x plus 4. And so this right here would be the factor. Okay, now this might be the first time you see that, so it's okay if it's a little fuzzy. Let's look at another one. Okay, so same concept. We check to see if there's a greatest common factor. There's nothing that goes into all 3 terms evenly, so we can do our slide and divide method. We take this 4, we slide it over here and multiply to get a -40. We take this middle number right here, and it goes on the bottom. So we want to multiply to get a -40, add to get a -3, or subtract actually. Okay, so let's see what we can multiply to get 40. We have 1 and 40. We have 2 and 20. We have 4 and 10, and 5 and 8. Okay, we want to subtract and get 3, which would be this combination, but it needs to be a -3, so my bigger number needs to be negative. My bigger number is always this sign right here. So we have 5 and -8. So we have x and x plus 5 minus 8, but we're not done because we got to do the divide part. Now we divide by 4, divide by 4. So 5 over 4 doesn't simplify. We can go ahead and slide that in front of the x. So we get 4x plus 5. 8 over 4 does simplify to 2, so this turns into just an x plus 2. And now this is completely factored. Okay, so go through, do the practice on this, and ask questions where you have questions, and good luck on your factoring review.